So the type of graphs that the video didn't cover was what if you have an arrow on both ends? So let's look at this example. So remember domain, I'm going to look from the left of the graph to the right. Well, if you notice on the left of the graph, it doesn't stop right here. An arrow means that we're going to continue to negative infinity forever. Oh, that's supposed to be an infinity sign. That's okay. From negative infinity all the way forever and ever and ever. And then if you'll notice to the right of the graph, remember we're going from left to right. To the right of the graph, I see an arrow, which means that it goes to the right forever and ever and ever in the positive direction. So that's going to go to positive infinity. Okay, so if you look at the range, so that's bottom to top, same concept. On the bottom, I see an arrow, so negative infinity. On the top, I see an arrow, so positive infinity. So when a graph goes from negative infinity all the way to positive infinity, it's going in both directions forever and ever and ever. That means all numbers are included. Every single number in the world, every number. We call that all real numbers. Okay, so if your graph has arrows on both ends, if it is linear, if it's a straight line, your domain and your range are going to be all real numbers. Okay, let's look at another example. If you have, what's that graph? Okay, this graph. Okay, I have a straight line. I see arrows on both ends. Same concept here, okay? Okay, on the left, I see an arrow. On the right, I see an arrow. So I know on the left, it goes to negative infinity, and on the right, it goes to positive infinity. So for my domain, I'm just going to call it all reals. Okay, same thing for my range, bottom to top. Those are your y values. On the bottom, I see an arrow. On the top, I see an arrow. Same thing, all reals. Okay, so those are pretty easy. If you have a straight line, arrow on both ends, it's all real numbers. But let's look at an example where you might have arrows on two ends, but not necessarily a straight line. Okay, so this example, we see, let's start with the domain. Okay, domain from left to right, this is a set of all x values. So if I look here on the left, I can't necessarily draw a line here because I have an arrow. On the right, same thing, can't necessarily draw a line here because I have an arrow. So my domain goes from negative infinity to positive infinity. So my domain is all real numbers. I'm just going to put all reals. Okay. However, my range is a little bit different. My range, okay, you want to start from the bottom to the top. This is a set of all y values. So if I look at the bottom here, ooh, I don't see an arrow. I see a line here, and it looks like it's touching at -6. But if we look up to the top, there are arrows on both ends at the top. So my graph at the bottom starts at -6. That's my smallest value. However, my highest value is infinity because this graph is never going to stop going up. Okay, so since it's all values, all of my y values, since that line is above the -6, then that means that all of my y values are greater than or equal to -6. Okay, if the line had been below the -6, then I would have said all of my y values are less than or equal to -6. Since it's above, it's greater than. If it's below, it's less than. Okay, what other examples have arrows? Okay, this one has an arrow as well. So we can look at domain first. Okay, domain is a set of all x values. So x runs from the left to the right. So let's start on the left. I see an open circle on the left, but on the right, I see an arrow. Okay, so all of my x values, okay, if we're going to the right, then your numbers are greater than this -5. Okay, so we can say that all of my x values are greater than or equal to -5 because we had a closed circle here. All right, it's greater than or equal to. If this line had been to the left of the -5, we would have said less than or equal to. Okay. All right, looking at the range, you want to go bottom to top. This is a set of all y values. Oh, so starting at the bottom, the arrow is at the bottom. So this goes to negative infinity at the bottom, and at the top, it stops at +5, and it is a closed circle. So what this is saying is that since the graph is below the 5, that it is less than or equal to all of our y values. So all of our y values are less than or equal to positive 5. So when you only have one endpoint and an arrow on another end, you are not going to have your x value in between two numbers. You're not going to have your y value in between two numbers. You're just going to have your variable first, just like we talked about with inequalities. Your variable has to go first, and then your constant has to go at the back. And ask yourself, is that graph greater than, sorry, I didn't mean to erase it, greater than or less than that point? Okay, was there any others I wanted to look at? Okay, let's do a circle just to get some more practice. All right, so domain. We're going to go from left to right. It's a set of all x values. So on the left, we have -4. To the right, we go to 2. So our smallest value is -4. To the right, we have 2. Notice I have 2 endpoints, so I have 2 numbers. Domain is a set of all x's, so your x goes in the middle. If you don't have an open circle or a closed circle, then assume that the line touches, and if it touches, then it's equal to. So less than equal to, less than equal to. Same thing for your range. You want to go bottom to top. That's your y values. So bottom would be -1, top would be 4. So -1 all the way to 4. My y values go in the middle. Assume that it touches if you don't have the circles. So if it touches, it's equal to, so less than equal to, less than equal to.